Okay, Assalamu alaikum. Welcome to lecture 19 of data mining. So today we will discuss a couple of more concepts and ideas from clustering. And I think that would be then the end of the algorithms in clustering. From the next lecture, we will then talk about cluster evaluation, which might take a lecture or two. So in the previous lectures, we had discussed density-based clustering, which using the algorithm called dbScan. We also talked about Birch and agglomerative clustering, which are both examples of hierarchical clustering. So today we will discuss graph-based clustering. We won't go into algorithms for this category. We'll just discuss some ideas. And then I will discuss the general concept of deep clustering, which is becoming more popular nowadays. And I think that would be the all for today. So are there any questions before we start with new content? So we do have a quiz at the end of the lecture today, starting at around 6:05. So are there any questions? All right. So we had discussed several clustering algorithms, and those clustering algorithms were placed in various categories of algorithms. We talked about prototype-based clustering algorithms. We talked about density-based clustering algorithms. And today we will talk about graph-based clustering algorithms. We also discussed other categorizations. One other categorization was partitional clustering algorithms and hierarchical clustering algorithms. So there are various ways of categorizing clustering algorithms. So one way is based on how we represent the clusters. And in this category, we have prototype-based or representative-based clustering algorithms, and then we had density-based. And now, briefly, we are going to discuss graph-based. Okay, so what is the idea behind graph-based clustering? So as the name suggests, we have a graphical representation of the data set. And based on that graphical representation, we define our clusters. So in the simplest sense, a cluster is a collection of highly connected objects. So connected objects in the sense that we have a graph, the nodes are objects, and the edges represent the connection between the graphs, between the objects. So the data is represented as a graph. Okay? Nodes are objects. Edges represent connectivity, or you can say proximity between objects. Okay? All right. So if you have a graphical representation, okay, first of all, how do you get this graphical representation? So there are actually a number of ways of getting this. One way is your data, let's say, naturally has a graphical representation. So natural graph representation. So you can think of data sets that have a natural graph as its representation. So for example, so Facebook connectivity data, for example, nodes are individual persons or entities on Facebook, and connectivity could be whether those two are friends, or connectivity could also mean whether they communicate or share updates among themselves. So similarly, you can think of Twitter, and you can think of other networks, for example, even the communication networks that we have, the internet, for example, the web, for example. Pages are nodes, and hyperlinks would represent edges between the nodes. So in this case, you have a natural representation of the data set as a graph with nodes representing the objects that we want to cluster, and the edges representing some form of connectivity appropriate for that type of data. Okay? Okay, so there could be other examples. For example, you can have examples from bioinformatics, from biology, you can have examples of social sciences. So naturally, data does have a natural representation as a graph. So that is one scenario. So another scenario is that you have to create or construct a graph. So graph does not naturally exist, but you can construct a graph. So how can you construct a graph? This usual way is that you map the proximity matrix to a graph. So proximity matrix, similarity matrix, or dissimilarity matrix, depending on what you're considering, what similarity function or proximity function that you have. Okay? So let's say you have n objects. Okay? So then this proximity matrix has a psi of n by n. And in the vast majority of cases, this matrix would be symmetric. Because, and of course, what is this matrix? This matrix, let's say, I denote this matrix by D. Okay? So Dij is basically the, you can say, dissimilarity between object I and object J. And in general, Dij is equal to Dji, because most similarity functions are symmetric. It doesn't matter whether you put one object before and the other object, the similarity is the same. Okay? So that's why the matrix is symmetric. So obviously you can develop a proximity matrix if you have a similarity function or proximity function defined for that data set. So from this proximity matrix, you can then build a graph. Okay? So किस तरह हम बना सकते हैं? So what does this matrix actually means? For example, Dij की कोई value है. Let's say this is distance है. So let's say distance usually is not normalized. So let me say this is 2. Okay? In some units. So this is the distance or dissimilarity between object xi and object xj. So xi is a node, xj is also a node. So this edge between xi and xj would then have a weight of 2. Okay, so let me see. So basically ग्राफ रिप्रेजेंटेशन में ये दो नोड्स होंगे, ये xj है इधर, इधर xi है, and the link between them would be weighted and the weight is 2. Okay, and obviously if you have more than 2 objects, usually you will have more than 2 objects in any real world data set. You will have a connected kind of graph, various nodes, connectivity आपके पास होगी, ठीक है, and all of these edges would have a weight that represent the similarity or dissimilarity, whatever you're using between the two objects. Okay. So that's another way of getting a graph. Okay. But there is a slight issue with this representation. So usually the matrix D is not sparse. So whenever you compute the similarity between two objects or dissimilarity between two objects, you will get a value which is non-zero. Okay? So distance, you will get a value which is non-zero. And which basically means that the graph would be dense, not sparse, which also means that they are high connectivity. So every object is almost connected with every other object. Of course, some of those connectivities की weights कम होंगे, but connection होगा. So the problem with this is that for most graph clustering algorithms, perform purely for dense graphs. They perform much better on sparser graphs. So ideally, we would like a representation that is sparser. Not every object is connected with every other object. Okay? So how can we get sparser graphs from a similarity or proximity matrix? So one way is that you can threshold the proximity value. Okay? So for example, if the proximity matrix is dissimilarity, we can say that Dij, if Dij is greater than, so this is dissimilarity. So if it is greater than some threshold, let's say, whatever कोई आप variable दे दें, let's say A, ठीक है, then basically dissimilarity, and then drop the link between xi and xj. Okay? So in this way, you can force the graph to be sparser. So if 2 points are further away or far away, meaning that their dissimilarity is greater than A, then you can remove the link. So you'll get a sparser graph as a result. Okay? So that's one way of creating a sparse representation or a sparse graph. So another way is to use the k nearest neighbor approach. Okay? So how does this approach works? So we basically say that so basically retain links to the closest, let's say, k neighbors. Okay? So let's say k is 3. So you only retain the connectivity with the 3 nearest neighbor of each point. So of course, if a point is connected with every other point, you just retain the closest 3, meaning those with the least dissimilarity. Okay? So this would also give you a sparser graph for the data set. Okay? So among the two approaches that I mentioned for getting sparser graphs from dense graphs, one was using thresholding, the other was using the k nearest neighbor. Which one would you prefer? So for clustering, generally the k nearest neighbor approach is preferred. So why? Because through the k nearest neighbor approach, we are able to model the density of the neighborhood. So for example, एक जगह पे आपके पास, of course I'm drawing this to scale in 2D. So let's say आपके पास points हैं बहुत सारे करीब करीब, तो इसके k nearest neighbor जो होंगे छोटे होंगे. Let's say you have in the same data set points are far away. इसके जो k nearest neighbor, of course area बड़ा हो जाएगा. So if the region is sparse, your nearest neighbor will be further away. If the region is dense, your nearest neighbor will be closer together. So in other words, dynamically, you are kind of adjusting to the density of the data. So on the other hand, if you had used a global threshold on similarity, you would have had no connectivity between sparse points. All those sparse points would have had no connectivity. They would have automatically become outliers. So one global threshold may not be appropriate for an entire data set in which density might vary a lot. While in the k nearest neighbor approach, it can adjust to varying density in a particular data set. Of course, you can change the value of k. So k can be any value. So k can be, let's say, 1 even. K could be, for example, 5, and so on. Depending on what k you set, you can adjust the connectivity of your graph. But for any value of k, it will adjust to the density that exists at that particular, you can say, region in your data set. So using any of these approaches, either your data set is naturally in a graphical format, or you're using a dissimilarity or matrix to create the graph. Now you have a graphical representation of data. You can apply some graph clustering algorithms to get your clusters. So we are not going to go into the details of these algorithms. And of course, there are some out there, but usually they're not very popular for mainstream data sets. They might be popular for data sets that are naturally graphical in nature. Let's say Twitter ka data, or Facebook ka data, or bioinformatics ka data. It is less common to first convert your data into a graph and then apply a graphical clustering algorithm. Okay? So the traditional way, of course, for partitioning a graph is the min-cut algos that you might have studied in some algorithms course. So min-cut basically क्या है? कोई भी आपके पास ग्राफ है, it splits the graph into two such that the splitting edges have the minimum weight. So अब weight हमारा क्या था? Dissimilarity था, ठीक है? So dissimilarity एक्चुअली यहाँ उल्टा करना पड़ेगा, मैक्स कट हो जाएगा मिन, फिर लेट्स से आपका एजेस वेट है वो सिमिलैरिटी है, तो मिनिमम सिमिलैरिटी वाले एजेस आपने कट कर दिए तो वो आपके दो एजेस, दो ग्राफ्स बन गए. सो फॉर एग्जांपल लेट्स से आपके पास कोई बनता है सिंपल सा नेटवर्क इस तरह बन रहा है. सो ऑब्वियसली if you apply the min cut, इसको इधर कट करेगा because this is the only one link between those two subgraphs, ठीक है? And of course this one link मैंने distance लंबा बनाया है इसका, it means that similarity थोड़ी है या dissimilarity ज़्यादा है. So this would be the edge that it would cut, and then you will get two portions, and those two portions would be clusters, and then you can do it recursively. Once you have those two clusters, उनमें फिर आप min cut apply कर दें. So this is kind of like bisecting. You have one cluster, then bisected, then bisected, and bisected. You get a hierarchy of bisected clusters. Obviously, let's say if you have a graph and you have a group of points that are fully connected, मतलब 3 points हैं, so they are all connected to each other. So this in the graph terminology is called a clique. So clique obviously is a natural choice for a cluster. ठीक है, 2 points का clique obviously वो दोनों linked हैं. 4 points का clique जो होगा वो इस तरह का होगा. Everything is linked to everything else. So if you have a clique, then that is a natural choice for a cluster as well. ठीक है? So, and then there are some other algorithms that are based on connectivity, that are based on weights, that are based on considering. You can consider, by the way, in a graph based, you can consider other information as well. Each node में आपको vector भी attach कर सकते हैं. So, for example, each node is a user. तो user की कुछ information as a vector भी represent कर सकते हैं. And then you can use that as well as the connectivity to do the clustering. So, so that's basically what I wanted to introduce in graph-based clustering. Specific detailed algorithm मैं discuss नहीं करना चाह रहा. ठीक है? And then of course there are other algorithms as well. ठीक है? But we are not going to go into the details. Okay, moving on. Any questions so far? Oh. Okay. So moving on, I'll discuss the relatively newer idea of deep clustering. So deep clustering is actually not a clustering algorithm. It's an idea of clustering using neural networks. So it's not one algorithm. So one of the main motivations for deep clustering is that, so actually there are two main aspects to this. One is, of course, yes, we do have a quiz. I think we mentioned that last time at 6:05. Okay, so deep clustering, one of the things that it's good at is it can handle mixed data types well. and I'll talk about this shortly. The second thing is that works well for high dimensional data. And high dimensional data is quite prevalent in nowadays, in practice nowadays. And most of the techniques that we studied previously, DB-scan, for example, Birch, or even K-means to some extent, they are well suited for low dimensional data set, meaning that when you have the number of features are in the dozens at most, maybe maximum 100. But when you have features that go into the thousands or tens of thousands, then they don't do work well because they are based on similarity. So if you have a very high dimensional data set, let's say 1000 ka vector hai, this is the 1000 ka vector hai, you're talking about 1000 dimensional space. So 1000 dimensional space mein similarity would always be very high. So you won't be able to distinguish between small similarities. You won't be able to distinguish the small similarity differences. Everything would seem to be like on the fringes. So by the way, this is the idea of curse of dimensionality. If you have very high number of features, when you have high number of dimensions, everything appears to be on the edges of that space and they will be far away from each other. So clustering using traditional techniques do not work well in that scenario. And finally, the third thing is basically usually they are end to end, of course, not always, and good at representation learning. So you can develop a low dimensional representation as part of the neural network, as part of the deep clustering approach. Okay? So you start with raw representation and you get the clustering. So that's why it's called end-to-end. Within that network, you are getting richer representations and you're doing this automatically. So that's why this is called representation learning. Okay, now let's talk about these ideas now. So first of all, how can it handle mixed data types? So usually we convert all attributes to have numbers because obviously neural network must process numbers. Okay? So how do you do that? We had already mentioned this previously. We use the one hot encoding for categorical. So if you have any categorical attribute in your data set, you use the one hot encoding to represent it as a vector of 0 and 1 with only 1 for the particular value and zeros elsewhere. So in this way, and of course, numeric attributes remain numeric. Categorical would become 0, 1. And if you have any binary attribute, that also remains 0, 1. But if you, obviously, if you use this encoding, you also increase the number of dimensions. So for example, if you think of textual data, and let's say you have a document of 30 words, okay? Each word is, for example, represented by a vector of size, let's say 1000, because one hot encoding आपने करनी है, ठीक है? 1000 means that there are 1000 distinct words. So what would be the dimension or the number of dimensions? There will be basically 30 into 1000. 30,000. So huge number, huge dimension. So for such huge dimensional data set, if you apply the k-means, for example, and compute the Euclidean distance or even the cosine similarity, then you won't get very meaningful results. Okay. So for a neural network, we can take this entire feature as an input, and within the neural network, we can reduce the dimensions. So that is where the learning representation or representation learning comes in. Okay. And then I also mentioned so both mixed data types and multidimensional are considered, and then end-to-end. So let me now first specifically talk about one approach. So obviously, I won't be able to go into the details of a neural network. So I'm going to show you the schematic input-output type of thing, and the math behind what happens. I don't think so. We will be able to cover in this course. So one of the architectures, one approach to deep clustering is learn richer and shorter representations using an auto encoder. And then after you have the richer and shorter representations, you can do a separate clustering. And that separate clustering now can even be use a regular algo like the k-means. Okay? So let me first talk about this. So in this case, you are using an autoencoder. Autoencoder is a specific type of supervised neural network which has an input layer, may have multiple hidden layers, and then we have an output layer. Okay? It is supervised, meaning that we will train it with exact labels at the output. And I will mention what those labels are. It is supervised. Okay? So what do we have as input? We have input as our object representation vector x. Okay? Okay? And as I mentioned before, it could be very long, like 30,000. One hot encoding आपने की हुई है 30 words की. Okay? So this is my input. My output is actually the same as x. ठीक है? So autoencoder में output वही होती है. ठीक है? So in other words, जो मेरे पास डेटा सेट, जो क्लस्टरिंग का डेटा सेट है, वही मेरा इनपुट बनता है, वही मेरा आउटपुट बनता है. n के बजाय मैं m कर देता हूं उसको. My data set of course is what? x I is equal to 1 to n. इस x n objects को मैंने क्लस्टर करना है, right? And that is all I have. I don't have any labels. Remember, clustering is unsupervised. But autoencoder, I use the same vector as my label at the output. So how does it work? So I will feed each of these x into my network. So x आपका जो input layer है उसका size m होगा. Equal to the size of the input. And then hidden layers, let's say आपके पास one hidden layer है, let's say only. So इसका जो size होगा, it would be some value, let's say इसको dimension में क्या दूं, let's say m1 कह देता हूं उसको, m1 that is less than m. ठीक है? And then we have output. इसका size of course is again m. So आपका जो network जो बनता है, so if I draw then in terms of layers, आपकी जो input layer है ये, फिर आपके पास बीच में एक hidden layer है, और फिर output layer भी full size की है. ये m की है, ये m1 है, और ये आपके पास m है. Of course between the layers you have connectivity, fully connected feed forward neural network है. Of course ये different networks भी हो सकते हैं auto encoder में, CNN भी हो सकता है, LSTM भी हो सकता है, depending on your data type. But here let's assume they are just feed forward networks. So input में आपने x दिया है, it goes through a nonlinear process. Inner product होता है, sigmoid multiply होता है, goes to the output. अब output में आपने वही input regenerate करना है. So x आपका input पे आया, it goes through the hidden layer and then it goes back to the full size of m. So जो hidden layer है, it is the smaller, the output of the hidden layer is the representation that we actually trying to learn. ठीक है? So this is smaller than m, m1 is smaller than m, let's say 100, 200 maximum. Okay, and of course m could be very large at 30,000. So first we encode, आप समझ लें कि इसको encoding कर रहे हैं, representation develop कर रहे हैं, m to m1, and then we decode back to m. ठीक है? अब इसकी learning किस तरह होगी? So learning इस तरह होगी, जो हमारे पास decoded output आएगी. Let's say जो output मैंने x input किया network को, और मेरे output y आया. Of course, x and y would be of the same size. ठीक है? And of course, y ideally should be equal to x. ठीक है ना? But of course, it will not be equal to x because we are decoding from a representation. ठीक है? So अब हमारे पास जो error है वो basically क्या है? Here, of course, all of those values will be continuous. So we are going to minimize the sum of the squared error between x and y. ठीक है? So that would then be, so this is basically vectors में लिखूंगा तो क्या बनेगा? Sum of squared error. So x minus y. So let's say ये vector था तो ये transpose हो जाएगा x minus y. So this is basically the you can say inner product of the difference of the two vectors. So we will try to minimize this at the output layer. And of course, through that minimization, the network is adapted. Okay, so in other words, in neural network terminology, this is my loss function, is the sum of squared error. So I minimize this loss function over the entire training process for the entire data set. Once I have done that, let's say my network trained ho gaya, then what I will do is I will feed in any given vector x, let's say 1, okay, which is of course of size m, network trained hai, and take the output of the hidden layer, which is let's say a1. इसका size of course क्या होगा? m1 होगा as its representation. ठीक है? So इसी तरह मैंने x2 भी डाला, उससे a2 आ गया, x3 भी डाला, a3 आ गया, so on. So I now have a new data set a, ठीक है? Of course, a is a vector, but now a is of size which is much less than m, and also it is dense, not sparse. There's very few zeros. So now you can go ahead and cluster यूजिंग एज, ठीक है। सो इन अदर वर्ड्स क्या हमने किया, ऑटो एनकोडर से हमने एक dense and short representation learn कर लिए, and my input could have been categorical, could have been mixed, could have been numeric, could have been binary, could even be images and whatever, सारी चीजें आपने नेटवर्क को दी और वही आपने पहले इसको एनकोड किया इनटू M1 आउटपुट्स, फिर डिकोड किया इनटू अगेन M आउटपुट्स, और आउटपुट पे फिर आपने चेक किया कि आपकी इनकोडिंग डिकोडिंग सही हुई है कि नहीं हुई। वो आपका लॉस्ट फंक्शन था जो आपने मिनिमाइज किया, and you have trained or learned this network. Once the network is learned, फिर आपने एक दफ़ा फीड किया x1, x2, x3, और जो हिडन लेयर के जो आउटपुट थी विच इज़ a, वो आपने यूज़ करके फिर क्लस्टरिंग की यूजिंग एनी अदर टेक्निक, लेट्स से k-means या db scan and so on. So any questions here? I mean, is this process clear?
सर आप हिडन लेयर का दोबारा समझा सकते हैं कि आप उससे किस तरह से रिप्रेजेंटेशंस लर्न कर रहे हैं?
तो हिडन लेयर जनरली जो प्रोसेसिंग उसकी होती है, सो लेट्स से इनपुट आपका x है, ठीक है ना, और सो लेट्स से सो अगेन फिर मैं आपको फिर बता देता हूँ फिर स्ट्रक्चर जो है एटलीस्ट फॉर फीड फॉरवर्ड। ऑफ कोर्स ये जो आर्किटेक्चर है लेयर बाय लेयर, ये कुछ और नेटवर्क भी हो सकता है, LSTM भी हो सकता है, CNN भी हो सकता है। ऑफ कोर्स दीज आर टर्मिनोलॉजीज फॉर न्यूरल नेटवर्क, और फॉर द स्टैंडर्ड फीड फॉरवर्ड आई कैन शो यू द इक्वेशंस देन, ठीक है। सो फीड फॉरवर्ड न्यूरल नेटवर्क में लेट्स से M मेरे पास जस्ट टू मेक इट कॉन्क्रीट 100 था, M1 मेरे पास लेट्स से इज इक्वल टू 10 एंड ऑफ कोर्स एंड आउटपुट पे फिर आपके पास 100 है, ठीक है ना। सो वी हैव 2 लेयर न्यूरल नेटवर्क, इनपुट लेयर को टिपिकली हम काउंट नहीं करते लेयर्स में। बिटवीन इनपुट एंड आउटपुट लेयर वी हैव ए वेट मैट्रिक्स W, लेट्स से आई कॉल दैट W1, और एक बायस वेक्टर B1 है, और फिर फ्रॉम हिडन टू आउटपुट लेयर एक और मेरा वेट एंड फिर B2, ठीक है। तो ये मेरे पैरामीटर्स हैं विच आई विल लर्न ड्यूरिंग द training process by minimizing the loss function. So when I have done that, I will feed in X. So my A, which is the hidden layer output, would then be given by the sigmoid function or logistic function applied to each element of the vector, W1 multiplied by X. This is vector, W is a matrix, X is a vector, plus B1. Of course, ये जो W1 into X would give you a vector, B1 is also a vector, total ये vector है। वेक्टर पे अपने एलिमेंट बाय एलिमेंट सिग्मॉइड अप्लाई करना है, तो जो आउटपुट आएगा वो ए, वो भी वेक्टर होगा, बट ए का साइज होगा ऑफ M1. सो दिस इज द आउटपुट दैट वी वांट, एंड दिस आउटपुट इज द रिचर रिप्रेजेंटेशन, द डेंसर रिप्रेजेंटेशन फॉर माय एक्स, ठीक है। सो ऑफ कोर्स जो नेक्स्ट जो ट्रेनिंग में आपको नेक्स्ट स्टेप जो होगा वो भी मैं लिख देता हूँ सिंस आई एम राइटिंग दिस। वाई बेसिकली आपका होगा अगेन यूजिंग ए सिग्मॉइड, ठीक है, W2 इंटू A प्लस B2, ठीक है। तो ये आपका फाइनल आउटपुट नेटवर्क का आ गया। अब Y और X को आपने मिनिमाइज करने की कोशिश की लॉस फंक्शन से, उस मिनिमाइजेशन में W1, W2, B1, B2 फिक्स हो गए, लर्न हो गए। जब लर्न हो गए तो उसके बाद सिंपली जो पहला स्टेप है, जो पहली इक्वेशन मैंने लिखी है जिससे A निकाला, हर एक X का A निकाल लें, वो A एक आपकी छोटी रिप्रेजेंटेशन होगी, वो फिर आप यूज कर लें और इन एनी अदर एल्गोरिथम लाइक K-मीन्स और DB स्कैन। ठीक है? Is this now clearer?
ठीक है, yes sir.
So sigmoid function is basically the S function between 0 and 1. Sometimes we also use the tangent hyperbolic function, which is between -1 and +1. By the way, actually, is clustering में ना the tangent hyperbolic is generally recommended. So anyway, ऊपर मैंने sigmoid भी लिख दिया, that's fine, but tangent hyperbolic is more recommended for clustering and because you get a representation that has both positives and negatives. ठीक है, तो so we used an autoencoder. First, we trained the autoencoder, then we used the autoencoder to generate our lower dimensional representation, and then use that representation for our clustering. Okay? So this is one way of using neural networks, and this is also sometimes called deep clustering, although this is not truly end-to-end. Okay? जो end-to-end options हैं, उनमें variety थोड़ी सी ज़्यादा है. I don't know how I can explain this in a short lecture. End-to-end models, for example. So end-to-end का main मतलब ये होता है कि representation भी वही हो रही है और clustering भी वही हो रही है. ठीक है? So उसमें जो दो options मैं quickly बताऊंगा, उसमें ये है कि architecture typically उसी तरह ही होता है. You have input layer, some hidden layers, and then an output layer. But now the output layer would be, one option is output layer is the number of clusters that you want. Okay? So we have input, hidden layers, and output. So output size is number of desired clusters. ठीक है? और यहाँ फिर अब output layer पे फिर obviously since we have to train the network, अब इसमें loss function जो use होता है, इसमें दोनों loss function use होते हैं. It's a combination of auto encoder loss and cluster loss. So cluster loss में obviously वही जो हमने कुछ जो loss पढ़ा था, for example, while we discuss the K-means algorithm, we want to minimize the sum of the squared error of each object from its centroid. Obviously इसको किस तरह implement करेंगे, obviously थोड़ा सा different है. I don't want to go into those details. आपको इसकी implementation मिल जाएंगी in many libraries, तो वो automatically भी कर लेगा. So you don't have to worry about that too much. ठीक है? So दोनों आपने यूज करने. यूजली हम इसको इंक्रीमेंटली करते हैं. शुरू में हम ऑटो एनकोडर लॉस को ज्यादा वेट देते हैं सो दैट आवर नेटवर्क लर्न्स द रिप्रेजेंटेशन. एज हमारा नेटवर्क ट्रेन और होता जा रहा है तो उसको वेटेज कम कर देते हैं और क्लस्टरिंग लॉस का वेटेज बढ़ा देते हैं. और एट द एंड ऑफ द व्हेन द नेटवर्क कन्वर्जेस, आपके एंड पे क्लस्टरिंग वो प्रॉपर्ली लर्न कर लेता है, इंक्लूडिंग द रिप्रेजेंटेशन that is done through the hidden layers. ठीक है? So whenever now you send in a new object, end पे वो जो node fire हो रहा है या जिस node का maximum value है, that is the cluster number. ठीक है? So let's say मेरे पास end पे 10 nodes थे at output. It means that I want 10 clusters. और मैंने कोई एक object, specific object xi feed in किया. So if xi मैंने feed in किया तो जो मेरा output होगा, let's say मेरा third node has max value. This means that xi belongs to cluster 3. ठीक है? So इसमें अब क्या डिफरेंस है? एक तो ये है कि जो लॉस फंक्शन है वो डिफरेंट होगा. We are not just learning a representation, we also want to learn a clustering. So, and यूजुअली हम पहले जो रिप्रेजेंटेशन लर्निंग का जो लॉस है वो उसको ज़्यादा वेट देते हैं. एज द नेटवर्क कन्वर्जेस फिर हम उसको कम करके क्लस्टरिंग को हम ज़्यादा वेट देने शुरू कर देते हैं. एंड देन व्हेन फाइनल कन्वर्जेंस हो जाती है देन वी सेंड इन ए पर्टिकुलर ऑब्जेक्ट. जो आउटपुट आ रही है वो उसका क्लस्टर, जिस नोड का हाईएस्ट आउटपुट है वो उसका क्लस्टर नंबर है. ठीक है. एनी क्वेश्चन? Okay, I think these are the two options that I'm going to discuss briefly. The first option was use an autoencoder to learn the representation and then use any other clustering algorithm. It could be a neural network as well, but usually K-means or DB-scan type का algorithm होगा. Apply it on the representation that is learned. The other technique is end-to-end. The output layer represents the number of clusters, and we have a more sophisticated loss function for training this network, which is a combination of an autoencoder loss and a clustering loss. Okay. Once this network is trained, whenever we feed in any object, the node that has the maximum output represents the cluster number for that object. Okay. More traditionally, a neural network technique was quite common or popular for clustering, which is called the self-organizing map. So this might be useful in some applications as well. So you need to know this name also. अभी भी ये use होता है, but it has become less popular. इसका architecture slightly different है. But the good thing about self-organizing map is it would give you a very nice visualization as well, automatically. Visualization of the nodes of the output. वो आप maybe 2D में, 3D में उसको आप show करवा सकते हैं. ठीक है. ठीक है. Okay, so let's say if you have अब मैंने जो अभी ऊपर एग्जांपल दी थी with the equations, there was standard feed forward neural network, which means that all the input is one vector fed in at one time. But sometimes हमारे data representation or data is much more complicated. For example, if you talk about textual data is sequence. For example, textual data, let's say एक tweet है, उसमें 10 words हैं, but those 10 words have positions. So if you want to make sure that positions are also considered, then you can use their appropriate neural network equivalent. For example, you can use a recurrent neural network for encoding. Similarly, आप images हैं आपके पास, images में spatial information important होती है. तो spatial information के लिए convolutional neural network आप use कर सकते हैं for encoding. And of course, you can combine convolutional, feed forward, recurrent also for encoding. So the point that I'm trying to emphasize is this neural network or deep neural network approach gives you greater flexibility. You can handle different types of data in the same framework. So for example, let's say if you're processing Twitter information, so text information भी होती है, Twitter में audio भी आ जाती है, Twitter में आपके पास images भी होते हैं, video भी होते हैं. सारों का एक फीचर वेक्टर बनाएं, मल्टीपल आपके पास इनपुट्स आ जाएं, सारों की एक रिप्रेजेंटेशन बना दें. अब वो रिप्रेजेंटेशन आपके पास छोटी सी होगी, मे बी 200, 300, 1000 के होगी, बट इफ यू कंसिडर ऑल दोज थिंग्स कि एक ट्विटर स्ट्रीम में टेक्स्ट भी है, इमेजेस भी हैं, ऑडियोज भी है, सब कुछ है, उसको करेंगे तो मिलियंस ऑफ फीचर्स बन जाएंगे, बट यू कैन प्रोसेस देम टू गेट a dense representation and then use that dense representation for clustering. ठीक है? So I think that is pretty much it about the idea about deep clustering. And I would also say that this has become quite popular in practice in the past 2-3 years. Industry में अब ये काफी commonly use हो रहा है. So if I want to summarize जो तीन या चार algorithms the most commonly used होते हैं, of course k-means है, which is quite popular. DB scan quite useful है because it gives you clusters that are of arbitrary shape. But DB scan की limitation ये है कि ये low dimensional data पे ही अच्छा चलता है, high dimensional में issues आते हैं. उस पे चलाना है तो पहले आपको ऑटो एनकोडर से लो डायमेंशन स्पेस बनानी पड़ेगी. एंड देन ऑफ कोर्स डीप क्लस्टरिंग के वेरिएशंस क्वाइट पॉपुलर है nowadays. And one of the reasons for that, it can handle mixed data types, it can handle heterogeneous data types, images, videos, and so on very nicely. So with that, I think we have come to the end of clustering algorithms. Next, we will discuss how do you evaluate clustering. So still have about 5-10 minutes. Do you have any questions? Any questions? All right, so no questions. Chale, let's move on. So by the way, ये clustering validation जो है, I would follow more closely chapter or 7.5 of Intro to DM book. ये by the way, ये chapter मैंने upload भी किया था class से पहले on LMS, so you can find this chapter on LMS. And of course, this chapter has more detail on k-means, k-medoids, agglomerative clustering. वो भी आप supplementary reading के लिए पढ़ सकते हैं. और जो 7.5 है, जो evaluation है, mostly मैं यहीं से cover करूँगा. दूसरे book में इतना अच्छा नहीं दिया हुआ. ठीक है? Okay, so the first question is, why do we want to evaluate clustering? So remember, clustering is unsupervised. Okay? So we don't really have the true labels. And the whole idea of clustering was to determine some groupings for which we can then assign labels. Okay? So जब आपके पास true labels ही नहीं है, तो हम evaluate किस तरह कर पाएंगे? Of course, एक approach है कि true labels हैं, तो फिर आप evaluate कर रहे हैं, but वो let's look at other reasons. So we like to determine whether any given data set is clusterable, clustering tendency. ठीक है? So what is the clustering tendency? So कोई भी आपके पास data set है, do natural clusters exist in that data or not? So that's a question. And obviously, to determine this, you need to have some way of quantifying whether a clustering is good or not. So that's where clustering evaluation comes in. ठीक है? So clustering tendency हमने determine करनी है. Another reason why we like to do validation is, for example, determining K, for example, the number of clusters. So for k-means, k-medoids, we need to input K we need to provide K as an input. So what is the best K? And obviously, if I have K is equal to 3, 5, and 10, clustering तो कर देगा मेरा k-means, but मुझे किस तरह पता चलेगा 3 वाला बेहतर है या 5 वाला बेहतर है या 10 वाला बेहतर है? अगेन वैलिडेशन या इवैल्यूएशन वुड हेल्प अस, ठीक है। देन ऑफ कोर्स कंपेयरिंग क्लस्टरिंग एल्गोस, ठीक है। सो लेट्स से मैंने एक के मीन्स लगाया, एक डीबी स्कैन लगाया, एक डीप क्लस्टरिंग लगाया, हाउ डू यू नो दैट विच वन इज बेटर? सो अगेन टू कंपेयर we need some way of evaluating a clustering, ठीक है। I think that's pretty much it. Although book में शायद एका दुका और भी सब कैटेगरी बनाई हुई है, but I think those are the essential reasons why we would like to do clustering or why we would like to do cluster evaluation. So मेरे ख्याल से I think I'll stop here because we are also running out of time. Any questions? Any questions? Any questions? No questions?
No, sir.
Okay. So we are into the last 4-5 weeks of the semester. Workload obviously आप लोगों का ज़्यादा होगा, project भी आपका चल रहा है, assignment 3 भी है और maybe assignment 4 भी होगी. And then of course we have some content left as well. Clustering evaluation would be 1 lecture or 1.5 lecture. And then after that we'll talk about briefly about classification as I promised earlier on. And then उसके बाद we'll talk, उसके बाद actually outlier analysis briefly discuss होगा because outlier analysis is closely related to clustering. उसके बाद classification and then a bit idea of how to handle spatial temporal data. I think that by then we will be at the end of the semester.
सर आउटलायर एनालिसिस का क्वेश्चन है असाइनमेंट 3 में, तो वो तो अभी हमने पढ़ा नहीं, तो वो कैसे करेंगे फिर?
कौन सा वाला क्वेश्चन?
आउटलायर एनालिसिस का असाइनमेंट 3 में।
अच्छा ठीक है, तो आउटलायर एनालिसिस हमने अभी एक आध हफ्ते के बाद ही शुरू होगा, या वो मैं नेक्स्ट वीक शुरू कर नेक्स्ट लेक्चर में शुरू कर सकता हूँ, इवैल्यूएशन बाद में कर दूंगा। एक्चुअली
लेकिन नेक्स्ट में अगर आप स्टार्ट करेंगे तो वो
इवैल्यूएशन भी थोड़ा सा है उसके अंदर आपके असाइनमेंट में।
लेकिन वो अगर आप नेक्स्ट में भी स्टार्ट करेंगे तो डेडलाइन से पहले तो नहीं होगा, वो टाइम लगेगा हमें करने में।
सर डेडलाइन इस फ्राइडे की है बेसिकली।
अच्छा चलिए मैं देखता हूँ उसके बारे में क्या, अभी आप उसको आउटलायर वाला क्वेश्चन तो प्रॉबेबली थोड़ा सा उसमें ऐसे कौन सी टेक्निक यूज हो रही है वैसे मुझे अब याद नहीं है, असाइनमेंट 3 में क्या था, कौन सी टेक्निक बताई हुई आउटलायर में? सो जो डिफरेंट टेक्निक जो हम पढ़ते हैं वो LOF ही होता है। इफ इट इज नॉट LOF और इट इज बेस्ड एंटायरली ऑन क्लस्टरिंग फिर तो आप कर सकते हैं।
सर आई गेस LOF है उसमें।
LOF है, ठीक है, तो वो पोस्ट प्रॉब्ली फिर आप नेक्स्ट असाइनमेंट में डाल दें। And of course try to submit this assignment by Friday and get the next assignment by then. Move कर देंगे इसका next में, ठीक है।
Okay, guys, let's get ready for the quiz. So please turn on your cameras. सर आप अपनी स्क्रीन ऑफ कर दें।